Hi guys, welcome to my channel and today I'm going to explain you alpha beta pruning. So guys, what is alpha beta pruning? So alpha beta pruning is an extension of a algo which we use in games theory called as min-max algo. So in min-max algo, we try to find the maximum and minimum chances of one player or the second player winning. So for that we explore each and every leaf of that game tree. Okay, so now to increase our performance, so we have extension of min max algo, we call it as alpha beta pruning. So in alpha beta pruning, it is not required to explore each and every leaf or the node of the tree. Okay, so how it works, I will explain you step by step and in the end. So same example we will solve using min max algo also, so that you can know the difference. So guys, for the full video, all of you stay tuned.
karanjetlilive.
So guys, suppose this is our games tree. I hope it is visible to you. So in games tree, normally max min what we do. Okay, so here is the max, here is the min, here is the max. At max, what do? We explore these two leaves. Whatever is the maximum value, we will put here. For example, in this case, it will be 4. In this case, it will be 8. In this case, it is only one leaf. 2, 5, 1 and 7. Okay. So and so on. Here, out of these two, we will get the minimum value. Okay. So in max min, what happens? We explore each and every node. Each and every node. Now, this tree is small. Suppose our tree is very big. So then if we apply max min, it will take a lot of time to explore all the nodes of the tree. Now, what is an alpha beta pruning? As I told you, it is an improvement of max min algo. So it says, if any node does not change my result, then no need to explore it. So if my tree is very big and there are many nodes which will not change my overall result, so I should not visit them. It kind of increases the performance of your max min algo. So what do we call it? We call it as alpha beta pruning. Now how it works? Okay, so here guys, we have two variables. One is alpha, another is beta. Okay, so alpha represents your max and beta represents your min. So what happens is, at max, alpha value will change, and at min, the value of beta will change. Okay, now initially we will assign both alpha and beta. Alpha we will assign as minus infinity and beta we will assign as plus infinity. Then we will start exploring the tree in DFS manner. So what is DFS manner? Depth first search method. Okay, so guys, as I told you, alpha I assigned minus infinity. So this is alpha initially. What will the value of alpha? Minus infinity. And what will be beta? Infinity. Here is alpha again minus infinity. Okay, so since I told you it will use DFS algo, so I am at the root, so I will go to this subtree. Then from here I will come here, and from here I will come to this leaf. I will explore this leaf. Now, as I told you, at max, what will change? Alpha will change. Okay. Now, here value of alpha is minus infinity, and value of this node is 1. So, if I compare 1 with minus infinity, so which is bigger? 1 is bigger. So, here alpha becomes 1. Here alpha becomes 1. Okay. So, then from here, at max, I will look for some value. Which is greater than the value of alpha. Here initially the value of alpha is, first it was minus infinity, then we explored 1, we replaced it with 1. Now the value of alpha is 1, and here at 1, at this node, I am looking for some other value which is bigger than 1. So I go to this tree. Now 1 and 4 will be compared. Now which is bigger? 4. 4 is bigger. Okay. So now what I will do? So this node will get the value 4. I hope you understand it. Okay. So now this value will be propagated to the node above. It will be propagated to the node above. But above, what will change? Beta will change. So what is the function of beta? Any value. So since this is the min level, any value which is smaller than the present value of beta will be replacing the value of beta. Now here beta is infinity and the value which we are trying to propagate on the top is 4. Now if we compare infinity with 4, which one is small? Infinity or 4? 4 is small. So here beta will become 4. Here beta will become 4. So what comes here is 4. So what comes here is 4 for the time being. Okay. Now at this place, I am looking for some value. Okay. I am looking for some value which should be smaller than 4. Which should be smaller than 4 because it is min and still we have one subtree. Okay. So then what comes? I come here. Now here no value is there. Then I come here. So here what my alpha becomes? Alpha becomes 6. Okay. Alpha here becomes 6. Alpha was minus infinity here also initially. Now minus infinity is compared with 6. Which is bigger? 6 is bigger. 6 is bigger. So what comes here is 6. What comes here is, for the time being, what comes here is 6. Now here the pruning begins. Now at 4 we are looking for a value which is smaller than or equal to 4. Now here we already explored the full tree, subtree. Now here we explored only this part, okay, and we got value 6. Now here at 6 I am looking for a value which is bigger than 6. Why? Because it is max, which is bigger than 6. Even if I replace this 6 with 8, so the 8 cannot replace this 4. Why? Because here anything which is smaller than 4 can replace 4. Now already I explored one subtree. Here I get 6. Now can 6 replace 4? No. Why? 6 is bigger. Now here to replace 6 I need some number which is bigger than 6. So if 6 cannot replace that 4, so any number which is bigger than 6 can also not replace 4. So then is there any point in checking the value of this 8? No, isn't it? So then what we will do? We will prune this 8. What happens here is I come here. Here I am looking for something which is smaller than 4. Okay, and I have a subtree under it which I can explore. So I come, I explore and I find here 6. Now 6 is not smaller than 4. Okay, so 6 cannot go here. 6 cannot go here. Now here if I explore the other node, okay, so here what we can replace 6 is anything which is bigger than 6. Now guys, if 6 cannot replace 4, okay, so any number other than which is bigger than 6 can also not explore, cannot replace 4. So there is no point in visiting it. So we prune it. And we propagate the value of 4 here. Now here 4 becomes max for the time being. Now we have all this tree to explore so that we can find a value which is bigger than the 4. So then from here I come here. Okay. Now from here I come here, since no values are here, only alpha infinity and negative infinity, I come here. So here also initially alpha is what? Alpha is minus infinity. So when I compare this with 2, so what comes here is 2. Since it does not have any other leaf, so for the time being 2 comes here. Now here at this place I am looking for any value. Since this is min, I am looking for any value which should be smaller than 2. But on the top I am looking for any value which should be greater than 4, which should be greater than 4. Now guys, here is already 2. So whatever comes here will be smaller than 2. Whatever comes here will be smaller than 2 because it is a min node. Okay, so anything which is smaller than 2 can replace 2, but it cannot replace 4. Why? Because 4 is bigger than 2. 4 is bigger than 2. So here, anything which smaller than 2 comes, still it will not change my 4. It will not change my 4. So there is no point in exploring these nodes. So these will be pruned. These will be pruned. So we get 2. So ultimately our aim is to find anything which is bigger than my main root, isn't it? So here is 2. Since only the minimum value will travel here, so anything smaller than 2 will come. So 2 is smaller than 4. So anything smaller than 2 will be smaller than 4. So it cannot replace my 4. So I prune this. So I prune this. Now still I have one subtree to explore. Maybe I will find some value which is greater than 4, isn't it? So I come here. Since depth first search, I go here. Okay. Now here what value comes is 1. Here what goes here is 1. So when I compare 1 with 0, so 1 is max, so no change. So this one is propagated here. So this one is propagated here. Now again, I need some value here which can be greater than 4. Which can be greater than 4. But here I already got 1. Now to replace this one, the value which can replace this one should be smaller than 1. Should be smaller than 1. It can be 0, -1 or anything. Even if it is 0, it cannot replace 4. If it is -1, then also it will not replace 4. So already, even if it is 1, it cannot replace 4. So is there any point in going here and exploring this? There is no point, isn't it? So whatever value, see, I bring 6 here, then I replace it with 7. 7 is not going here. 7 is not going to come here. So since 7 cannot replace this min node, so then this cannot change. Okay, so there is no point in exploring this also. So what happens is, this is my winning path. 4, 4, 4 and 4. And in this, I did not explode this node. I did not explode this node. I did not explode this. I did not explode this. And I did not explode this. But my result is same. My result is same. Means even if I explore these and replace these numbers, these values with max and min, then also it is not going to change my result. So there is no point in exploring them. So when we have less number of nodes to explore, the performance of alpha beta pruning, it increases. The performance of alpha beta pruning increases because it has less number of nodes to visit and traverse. Okay. Now on same algo, on same thing, if I apply max min algo also, then also you will see the result will be same. So here let us do it. 1 and 4, which is max, 4 comes here. 6 and 8, which is max, 8 comes here. Okay, so 2 is only 1, so 2 comes here. 5 and 3, which comes here is 5. 1 and 0, which comes here is 1. 6 and 7, what comes here is 7. Okay, now here I explode and each and every node. Okay, between 4 and 8, so this is min, which goes here is 4. Between 2 and 5, which is minimum, 2. So between 1 and 7, which is minimum, 1. Okay, so then out of this, which is max, 4. So no effect on the result. No effect on the result, even if we do not explore these nodes. So we explored this tree using alpha beta pruning also, using max min also, but it did not change my result. But in alpha beta pruning, I did not explore this node, this node, this node, this node, and this node, okay, which kind of increases the performance of my alpha beta pruning. So guys, I hope you understand it. I hope you understand it. And guys, if you like my videos, please subscribe to my channel. I'll be uploading more videos on the topics related to AI, system analysis, object oriented analysis and design, and much more. So guys, all of you, thanks for watching and stay tuned.